We'll begin our review of sequences and series with some summation notation, or our capital sigma symbol. Now remember, this means we want to add together, we want to find the total of the first four terms in this sequence of 5 times 3 to the n minus 1. So this means that we need to plug in n being 1, n being 2, n being 3, n being 4. So I'm going to plug those in here. 5 times 3 to the 1 minus 1. 3 to the 0 is 1 times 5 is 5. Term number 2. 2 minus 1 is 1. 3 to the 1 is 3 times 5 is 15. Next term. 3 minus 1 is 2. 3 to the 2 makes 9 times 5 is 45. And our fourth term, 4 minus 1 is 3, 3 to the third is 27, and 27 times 5 is 135. So there's our four terms for this sequence, and now with the summation symbol, I'm going to add together those four terms, and gives me a total of 200. Now, if I've got a TI-84 calculator, I can also find this sum on the calculator by going into Math, and I scroll down to number 0, summation, and then I can type in what I want. My variable, I'll say, is x, starting with the first term, going to the fourth term of my sequence, 5 times 3 to the times 3 to the x minus 1. 200. This series of numbers, 5 plus 15 plus 45 plus 135, this is a geometric series because we are multiplying by a common ratio between each term. In this case, we are multiplying by 3. Now, knowing that multiplier, that common ratio of 3, then we can write our definitions for this geometric sequence or series. Recall that we have two definitions, a recursive definition and an explicit definition. The recursive definition is not so helpful. It basically shows us the pattern. So in this case, an, the next term, is an minus 1, or the previous term, timesing by our common ratio of 3. So that just shows to find the next number, we need to multiply the previous number by 3. And we're going to keep multiplying by 3 to continue the pattern going. The explicit definition, the one that's more helpful for us, is an equals the first term, which was 5, times r, which was 3, to the n minus 1. And you should notice that this 5 times 3 to the n minus 1 is right up here next to our sigma symbol. You always write the explicit definition next to the sigma if you want to find the sum of a sequence. So if I wanted to know the 8th term of this series or sequence without having to keep multiplying by 3, I can just plug in 8 for n. So I'll do 3 to the 7th times 5, which is 10,935. And that would be the 8th term in our sequence. Here's a new sequence of numbers that happens to be arithmetic, because now I am adding a common number, which we call the common difference between each term. So we're continuously adding 9. So for our recursive definition, this is easy enough to write. The next term is the previous term plus 9. The more helpful definition, our first term was 6, our common difference was 9, times n minus 1. Now I'm going to change this sequence into a series by putting plus signs between these terms. And let's write this series in summation notation. So there's my summation, starting with n equals 1. My explicit definition is going to come right over here. And now the only thing that I'm missing is the number of terms. So I could figure out the number of terms by actually listing all of these out, or I can use the explicit definition to figure that out, because I know the last term, my a, how many ever terms there are, is 114, is equal to 6, plus distributing here would be 9n minus 9. Combining like terms would be 9n minus 3. And now solving this for n, I'm going to do 117 divided by 9, which is 13. So I know that 114 is the 13th term in this series. So there's my top number on my sigma. So to actually find the sum, I could either add all of these terms together, all 13 of them, or I can type this into my TI-84 calculator, or I can use a formula from my reference sheet where it says sum of a finite and ending arithmetic series. So I have just figured out that there's 13 terms in this series, so I want the sum of 13 terms. So I'll do 13 times the first term, which was 6. A sub 13, or the 13th term, the last term, is 114. All divided by 2. So 6 plus 114 is 120. Half of 120 is 60, and 60 times 13 will be a sum of 780.